Okay, so today we'll start with this random signals and process, chapter 4, pairs of random variable. Okay, remember one thing, in the pairs of random variable, so far in our last classes, we talked about single variable random variable, isn't it? That means either X or Y, whatever it is. But today we'll talk about multivariable. Okay. In the chapter 2, and already I've told you that we'll talk about the multivariable. And in the multivariable case, we are having this X and Y. Right. So an example of two random variable that we encounter all the time in our research is the signal that is transmitted or emitted by a radio transmitter. And then another one is the corresponding signal Y that eventually arrives at the receiver. So these two variable X and Y, these two variables are actually varying at the same time. All right. So we are having two random variable where the variables are at the same time varying. I'm sending a signal, I'm receiving a signal. So if you want to see both the signal at the same time, X and Y, what is the correlation of between them? What is the covariance between them? So if we want to find out, then actually we need this combined analysis of random variable. Okay. The thing is, what is the topic that we want to see in the next? That one is this joint cumulative distribution function. Okay. So this joint CDF, when I'm talking about joint CDF, it is called joint cumulative distribution function. Okay. And in this joint distribution CDF, remember one thing, in this joint CDF, we are talking about fxy, where this fxy is equal to probability of x less than equals to x and y less than equals to y. Okay, so this is what, remember one thing, in our normal case, when we are trying to find out the fx equals to what? Fx is the probability of x less than or equals to x. Only this one. There is nothing regarding y. This y-axis, this, not actually this one, not actually this one, this y-axis. Okay, this is the y-axis. This y-axis, there is variable also in this time, but previously that was up to infinity. So actually we are not considering the y value, we are considering only the x value previously when we were talking about fx. And in this fx, x value is less than equal to x. But now in this joint CDF, we are talking about x value has to be less than x, and y value also we are making a boundary. Y value is also has to be less than y. So when I'm talking about this one, I am actually surrounding an area. This area where it is actually bounded by two values. One is the value of x, another one is the value of y. Okay. So this is the CDF. When I'm talking about CDF, actually this the area of the XY plane corresponding to the joint CDF is this area. All right. Is it clear?
Yes, sir.
Okay. Now, if I go back to the next slide, look at this one. This slide actually is about theorem 4.1. This one is about CDF characteristics. We can say this one is a CDF characteristics. Okay. In the CDF characteristics, we are talking about this CDF characteristics. In the CDF characteristics, what character actually has a CDF or the CDF has? Number one, the CDF is actually what? It's a kind of probability, summation of probability. So can the sum of probability be less than 0?
No, sir.
No. Can it be more than 1?
No.
No. So the CDF value has to be bounded by this 0 and 1 value. This is the CDF characteristics, number one. Number two is, look at one thing. fxy, xy. This is the CDF of xy. Now in this joint CDF, look at, if you can look at this thing, that is, I'm talking about xy point. But like the previous case what? When it was x only, that area was actually the fxx, isn't it? The value of y is infinity and x has only the variation. Either x will be increased or x will be decreased. So for that particular case, when x is the only variation, we call it fxx, the CDF of x. But when I am making x variable also y variable, then this is the joint CDF. Now, if in the joint CDF, I put the value of x equal to infinity or y equal to infinity, then actually we can get back to the single variable CDF. Say, for example, if I put x equal to infinity, that means that x has no variation now. This x has no variation now. So that is actually fy. So when the x value is infinity, then it is fy. When y value is infinity, this is actually fx. So the thing is, in the joint CDF or from the joint CDF, we can find a single variable CDF as well. Did you understand?
Yes, sir.
Okay. So this ABCD part we have already covered. Now what about this D part? Remember one thing, CDF. At this point, X, Y can be anywhere. If, say, for example, this X point is at minus infinity, like this kind of point, that beyond this one, there is no value. So if X equals to minus infinity, then this line or this point, say, for example, before that point, is there any probability?
No, sir.
No. So if there is no probability, sum of probability will be 0. So CDF at x equal to minus infinity, that will be equal to 0. Also, if you go in the y direction, y equals to minus infinity, like this line. So if I go beyond y, there is no probability. So if I say that if y equals to minus infinity as well, the CDF value or joint CDF value will be equal to 0. This one also. Do you agree?
Yes, sir.
Okay. That was the D case. What about the E case? Look at that. This one is something like xy. I have another point which is at x1, y1. If I talk about xy, then this is the area, isn't it? Or this is the CDF. I can say this is the fxy, xy. when I'm talking about x1, y1, where x1 is more right, y1 is more upper side, then the area covered by this has to be more than the previous area, isn't it?
Yes, sir.
This area
Yes, sir.
is definitely more than this area. So we can say that if it happens, then this is the criteria. fxy is less than fxy, x1, y1. Clear?
Yes, sir.
Yes,
And
sir.
this fxy, if it is goes to infinity, that is both x and y are going to infinity. That means what? At the extreme upper right point. So this one covers all the probability. So if I want to find out a CDF at this point, that will make it equal to 1, isn't it?
Yes, sir.
So if I go for both infinity, x and y as well, then actually we will see that the value of CDF will be equal to 1. Okay, so these are the characteristics for a joint CDF. Okay, for a joint CDF. All right, any question? Okay, if not, then we can go to the next slide. Now you will tell me, what is this? What is the value of first one? Do not see the answer. Do not see the answer. Okay, do not see the answer. Let's see this one only. Don't see the answer. Okay, look at this one. fxy minus infinity 0. Tell me what is the value?
Sir, f of y at 2. At y equals to 2.
Yes, so that's equals to 1.
Is it a minus infinity is there? When x is going to minus infinity, whatever the value of y is, will there be anything before that?
No, sir.
Just draw the figure. I'm going to x minus infinity and y equals to 2. That point is something like this one. And this is the extreme left side. This point is minus infinity 2. Now, at this point, if I want to find out the CDF, what will be the CDF?
0.
0. That will be 0. Okay, so don't confuse. Any one value, either x or y, if it goes to minus infinity, the CDF has to be equal to 0. What about this one, number 2?
So this will be 1.
That will be 1. Very good. That will be 1. What about this one? fxy infinity
Sir,
y.
1 again.
1.
No.
This is equals to fy.
Sir, 8 at f of
This is
y.
equal to fy, right? This will be equal to f of y. Because minus infinity, if you go, then it will be 0. But plus infinity has to be both to make it 0, to make it 1. To make it 1, both has to be infinity. That just like number 2. But number 3 will be fyy. What about number 4?
So it will be 1.
Y is minus infinity.
Sir,
What is that?
0.
What is that? Y minus infinity means what? Y minus infinity means it has gone to the bottom extreme. And then you're talking about x equal to infinity. You're going x equal to infinity, but in the bottom, there is nothing before that. So when I'm taking the area, I have to take the area like this. But in this area, there is no probability. So that will be actually equal to 0. Is it clear?
Yes, sir.
Okay. So actually today I don't want to go further. I want to stop it here. That's a very short class today, just to start the class after mid. So we are, I'm taking the class. Hopefully in the next class, inshallah, I will try to take a full class. If I'm okay, then okay.